Hello. Today I'm going to talk about diving into C++ internals of io.js. So as it has been already said, my name is Fedor Indutny, and I'm working on io.js and sometimes on Node.js. And eventually I think we're going to work on Node.js again. So this is a QR code of this slideshow and the link. So if you would like to follow it while I will be speaking, you could feel free to open it and play with it a bit. Okay, diving into C++ internals of io.js. And also it has an alternative title that I would like to speak about too, and this is a history of a git blame. Okay, C++ talk on a JavaScript conference. This guy must be mad. Why JavaScript developer would be interested in this? But like anyone cares about it or write in C++ a lot here. But in fact, if you ever tried to optimize your JavaScript code to squeeze out every possible performance improvement or memory usage improvement from it, you are most likely already written some C++ code. Many blog posts, workshops mention ways to optimize JavaScript. And some of the suggestions are to avoid creating properties on the instances of objects in runtime. It is also called avoid hidden classes, when speaking about V8 at least. And in case of following this suggestion, you usually declare the properties in the constructor of the class. And it looks really similar to the C++, because in C++ you always put the properties in the declaration of the class or the structure. Second suggestion is to avoid polymorphism, or in simpler words, to avoid having different types of values as in variables or arguments of the function. In this example, I have a function called add, and it just performs addition to numbers. And if I will pass numbers to it, like very often, it will be optimized for the case of numbers. But if I suddenly decide to pass the strings to it, it will de-optimize. And the compiler will eventually generate the code that will support both cases, for strings and numbers. So in the general case that I'm using here as numbers, it will be a bit slower. So here is a suggestion, avoid polymorphism. And it's really similar to C++, because you always declare types here, well, almost always. And third suggestion is to cache and reuse objects that are expensive to create. We do it in Node.js, io.js, we do it for parser, for HTTP parser, because it's quite a bit expensive to create because it goes from JavaScript to C++ and back to the JavaScript. So we cache its instances and reuse them once they are needed again. Works like a charm. And of course, it's the same in the C++ because you allocate memory manually here in most of the cases. So to conclude, first JavaScript is practically very similar to C++. So I put here a double equals because of this. IO and Node.js use C and C++ a lot internally, if you didn't know about it. And the reason for this is that V8 is written in C++. It has C++ APIs, C++ headers, and stuff like that. So if you will ever need to use it, you will most likely need to use either some wrapper or write C++ code. And the second reason is that it provides only ECMAScript APIs, which are pretty limited because of sandboxing. But it's kind of cool, unless you need timers or file system API or networking. So this is why we have Node.js C++ layer. And this C++ layer lives on top of the event loop, which is provided by libv. And C++ layer provides netsockets, DNS queries, APIs from file system to zlib bindings, and lots of other stuff. Coming back to alternative title, History of Git Blame, I would like to suggest learning subject by learning its history. And luckily, Node.js is using Git since its beginning, so the history of everything that we have ever done with C++ is in the output of the Git log and Git blame. In particular, if you look at the output of git log deps8, you will see the history of V8 fighting us, and in git log crc, history of us fighting the V8. Okay, Node.js begins. Not exactly like this, but with this commit. And commit log says add readme and initial code. Fortunately, I can't really elaborate much from this. So I did check out it, not yesterday, but close to it, and figure out that it had 2 C++ dependencies except V8. One was lib EBB, a weird name, right? And EBB was a HTTP server on top of the event loop for Ruby that Ryan Dahl has written before the Node.js. But now it was used at that commit only for parsing the HTTP. So not much, but I guess he wanted to stay in his comfort zone. Second dependency is liboi, which stands for library for output input. And it was used to create TCP server, and it was running on top of the libev. So it's kind of implicit dependency, so I didn't mention it in this list. Here is how the first ever JavaScript user code looked like for Node.js. It was just a single global process function which accepted a request argument that it was performing some stuff. But how was it organized internally? There was a server.cc file. CC is an extension for C++. Sometimes it's CPP. And this file was used for command line arguments parsing, for initializing JavaScript, for initializing V8, and loading user code from the first argument, executing it, and then execution flown to the JS HTTP request processor.cc. This file created HTTP server and was invoking this process function for every incoming request. Almost nothing was working at this point. So when I built it, I tried to execute it. It was throwing errors all over the way, but after some tweaking, I was able to run it and was reporting the incoming URI. So it was just a proof of the concept. Summary of what we could see in that version. There was one file to set up V8 and command line arguments. HTTP server was in C++ without any networking events emitted in JavaScript or any complex stuff that we have right now. And there was one C++ instance for every incoming HTTP request. This is kind of important because this way it provided the mapping from the C++ instance to JavaScript object. It was setting URI, headers, and methods on JavaScript object, and it was kind of mapping to the C++ instance. This is the pattern that we are going to use, and we are using it right now too, so this is important to note. Now we quickly jump to next commit. Commit log says use object rep base class for file, socket, and server. Much better now. So this means there is one API now to wrap all the objects. And the need in this API arose because there are now net server, net socket, file that are all the C++ classes that are mapped to the JavaScript objects. So they need to be mapped in some way, and to deduplicate the code, we created object rep. Well, actually, they created it without me. I wasn't doing any Node.js stuff at that point, but anyway. File structure as that commit was following. There was crc/node.cc file, which initialized C++ libraries, and then it invoked crc/main.js. You see, here emerges an important pattern that we are going to use even now. We are separating the consoles. So it's kind of usual thing. We try to do as much as possible in JavaScript in a simpler scripting language that can't crash, kill your program, and it's only the rest and stuff that we can do in the JavaScript we do in C++. So it is now executing crc/main.js, and this file loads user code. This file compiles it and executes it and calls everything that happens in user code. Another file in C++ is crc/http.cc. It provides HTTP server API, connection, and HTTP request classes. crc/file.cc/file.js is a future FS module. crc/process.cc has only exit method right now, and it will eventually become a future process object that we have now. crc/timers.cc provides just set timeout and set interval, so nothing surprising here. Just a side note, HTTP server is still provided by liboi, and Node.js is using libev for event loop and asynchronous networking. Quickly jumping to version 0.2, we see that it has grown a lot, matured a bit, and there was large movement in separating JavaScript from C++ here. So in the previous versions, there was still some stuff in C++ that could be done in JavaScript, and now we separated this almost everywhere where we can. Now, Node.js is using CommonJS for both userland modules and for internal modules, core modules. And we have introduced tons of new core modules in this version. File structure is following. We now separated stuff in the lib folder for all JavaScript core modules and CRC folder for their C++ counterparts. Just in case, dependencies live in debs folder. And this folder has everything from V8, htparser, caris for DNS, lib.io for asynchronous file system, and libev for networking and event loop. Object wraps that we previously seen that it was only emerging and was just created. Now it is a public API. And the community and the core team members has polished it out a lot. And it became much greater because of the community too. Previously, all C++ classes were exposed to the JavaScript user code as a global object. So it was kind of messy, internal stuff was visible everywhere, but since we are now using CommonJS, we decided to move them in a secret place, which is process.binding. So when you call it with, let's say, a first string, it will return binding with this name. And this binding contains just several functions and several classes. Every class and every function is mapped to some C++ instance. So it's one-to-one mapping. And it's pretty similar for other modules too, if you will try to call it. Okay, quickly jump into version 0.6 now. And what happened here? The most important thing is that libev and lib.io was replaced by libev. This was possible only because of lots of work by Ben Nordhus, Bert Belder, Ryan Dahl, and other people, which I'm really thankful for. And it is a major milestone for Node.js because we now have a Windows support in it. All because of libev. Quickly jump into 0.10. We could say probably only one thing. It was boring, but a bit stable. So we jump to 0.12 on io.js. And there are lots of new stuff. But we are interested only in C++ in this talk. Important thing to say. Now we are no longer using object wrap internally. And this is why it's important to learn the history, because if you take a look at it now, it will seem unreasonable to you. We are using async wrap class instead. And the difference between them is that async wrap has two fields that object wrap didn't have. One of them is parent, and the second is provider type. Provider type is basically saying what this C++ class instance is used for. For example, it could be file system, DNS, TCP, or zlib. And parent says, parent could be another async wrap, and says how this async wrap instance that you're looking at was created. Example. If you have a HTTP server and in the request handler you do asynchronous fs write, it will create a new async wrap. And this async wrap for fs.write will have a parent, will have a HTTP request as a parent of it. So if you will walk from this async wrap to its parent, you will see sort of, you could build a waterfall like in Firebug or something like this to figure out what happened, why it happened, and what kind of stuff happens in your application. This is a part of the tracing API that is still in works, but I think it will eventually be available in a simple way to the users. Okay, we have arrived now at the present point of the Node.js and io.js, so it's time to stop the software archaeology and learn some real stuff. So it's time to get into C++ internals, and we'll talk about interoperation, handles, reps, and maybe unicorns. Yeah, so there are two folders now, except dependencies, lib and crc. And there are two folders that we are interested in. When you call recur fs, it does nothing but just loads lib/fs, lib/fs.js and executes it. So there is no magic happening here. But no magic means that there is no fs operations to write, because JS is not capable of fs operations by itself. So it isn't capable of networking either, and it's for the best, believe me. Because of sandboxing, because you don't want Chromium to ruin your file system or crack SSH servers somewhere. But if you need fs write file sync HTTP request, you probably need lots of C++ stuff outside of the JS land. To figure out how it all plays together and how things are calling each other, I would like to suggest to learn by example. Though recurrfs is kind of boring because it works just with numbers. You know, file descriptor is just a number. When you open file, kernel is returning the number, and you pass number again. Pass a number is kind of boring. So let's move to recurnet. And it does following stuff. It creates sockets, obviously. It needs connect events when the connection is established. And it supports writes and supports meet and write callbacks. And all of this is powered by C++ machinery. So we are really interested in this. So how does lib/fs.js get this C++ stuff? By process.binding, as we already talked about. And the bindings that we are interested in are tcp_rep, which lives in crc/tcp_rep.cc, and stream rep. These bindings provide following JavaScript classes: TCP, TCP connect rep, write rep, and shutdown rep. Purpose of these classes is following. TCP holds the socket itself, and it has methods to perform reads and writes on it. And rep is something that you pass in to the TCP instance when you want to do some asynchronous stuff. So it's kind of request, I don't know. So I promised you an example. NetConnect works in the following way. First, a TCP instance is created. Remember, TCP is actually a JavaScript class that is mapped to a C++ class. So it's invoking internals of Node.js. Then it stores TCP in underscore handle of the net socket. I think probably raise your hand if you know what's underscore handle or if you've ever seen it. No one's seen it. Okay. Yeah, so if you ever used Net's API directly, NetSocket has underscore handle property, and this one points to a C++ instance of TCP class. Then it is parsing arguments to the NetConnect. As you probably remember, NetConnect accepts port callback signature, also port host callback, and options callback. So there are several ways to parse the options that you want to use for connection to it, and it needs to put them in separate variables to simplify how it works with C++. Then it creates rep stuff that I was talking about. So it creates TCP connect rep, and it's calling TCP connect rec port host. And then once C++ internals will connect to the host using event loop and a kernel, it will invoke request.onComplete. So this is why we need the request, because we would like to send a notification to the JavaScript code when the action is completed. So TCP socket usually leaves more than the rep. So the conclusion. Handles is like TCP. There are two types of classes, sorry. Handles, it's like TCP, UDP, even zlib is a handle. Reps are requests, so it's a sync request rep. And reps live much shorter than the handle instances, because you usually connect only once on socket, perform write before closing the socket, and stuff like that. File structure now looks like this. crc/tcp_rep.cc has TCP rep, TCP connect rep, and stream-based in io.js, and now it will be in Node.js too eventually, has a write rep and shutdown rep, and it's structured in the following way. But to figure out how it's structured in C++, we need to ask ourselves, we need to go from the point where JavaScript is starting to interact with the C++, and it's starting to interact from process.binding. So how does these C++ files that I was talking about tell JavaScript that they have some bindings to provide? They use following macro construction in C++ code. So if you will clone the io.js or Node.js project and open C++ file, you will see node module context aware built in at the very bottom of it. And it tells two things. First is the name of the binding. It is the same string that you pass to the process.binding function. And second is the function that will be used for installation process. And it has kind of the same effect as following JavaScript code snippet. So it just puts the binding onto some kind of internal hash map in C++ and sets initialization function here. So when you call process.binding, it does nothing but just following JavaScript code. it just gets the binding from the hash map and initializes it if it wasn't initialized yet. So what this installation function does? It initializes the model. Yeah, so it does similar things that happen in common.js. When you recur the model, it's actually executed only once, and then the result is cached. So this module gets exports objects as an argument, and C++ code is just put in various methods and C++ classes on this object. So when process.binding is called, and it returns with an object, as we seen in very first slides about the FS module. Okay, so with export function classes, yeah. Each exported JavaScript class has a C++ counterpart. So it has some class declaration with most likely a similar name in C++, and you could always figure out which class it is related to by just looking at that name and figure out where the binding lives in a CRC folder. Most of these C++ classes are actually inherited from the async wrap, so they have kind of similar structure and similar APIs internally. Okay. Before I go further, just small reminders that there are two kinds of classes, handle and reps. Handle is like TCP, reps, it's stuff that you pass when you want to connect or write. And certainly when you work with the JavaScript engine, when you map C++ classes to JavaScript objects, you should consider how this stuff will be interacting with a garbage collector. In fact, there are two different types of interactions that we have in Node.js. One is to let the garbage collector destroy stuff, and this is what happens to handles. When they are closed, when you close the TCP socket, it will be destroyed only when the V8 garbage collector will decide to do this thing. On the other hand, requests are manually destroyed by the C++ code, so there is no need to wait for the JC to collect them. And they are destroyed right after the sync action completion. So once rig.onComplete is called, sync it's destroyed and it's not available anymore. Okay, I guess you're pretty scared by now, yeah? Time to test your skills. Situation. Let's say that you debug io.js issue, and for example, io.js is crashing on some code that you wrote or you see in kernel or in core modules. And this code looks like this. So it just gets the binding with the name foobar, gets a foobar class out of it, and then it crashes when you try to instantiate the foobar class. So the question is, where will you search for a foobar? Okay, you don't have a microphone anyway, so I will answer the question myself. You will try to search somewhere in CRC folder, because this is a folder where all the C++ stuff of Node.js lives. And you will most likely will want to search for the node module context availability things that we were talking about, because it's the way the binding tells about itself to the JavaScript. And most likely this file will be named crc/foo_bar.cc or something like this. So it will most likely have a similar name to the binding name. Okay, I guess I have some time. Yeah, I have one. Not much. So I'd like to talk about one of my recent obsessions, and this is C++ streams. This is what we are trying to figure out in io.js right now, and would like to make it public eventually. And the reason I'd like to talk about it is because I want it to be public. And when things become public, they are usually polished out by community a lot and improved, and the API got improved and stuff is getting better. We did it for object wrap, and the results was fantastic. And I think we should do it for the streams in C++. And the stream wrap, which is actually a base class for the TCP, UDP, and stuff like that, it wasn't that bad in 0.10 Node.js, actually. But it was modified a lot for 0.12, because we moved TLS SSL implementation into C++ to make it faster. So it now looks terrible in 0.12. And there are several reasons why I think this is terrible. First of all, because we wanted to move TLS to the C++ from the JavaScript, we need some way to work with the data that's coming from socket and the data that comes to socket in the C++ without invoking any JavaScript events for performance reasons. And because we want this, we did some sort of redirecting of the output input to the callbacks. You see callbacks stuff. So it supports only one depth nesting. So it doesn't support redirecting it 2 times or 3 times. So it's kind of not good. And it may skip JavaScript callbacks altogether. For example, if TLS protocol is performing a handshake process where it sends certificate of the server and replies to this with some crypto crazy stuff. It doesn't really invoke any JavaScript callbacks yet because there is no connection to talk about yet. And it does some black magic inside, which is not great too, but performance is really fantastic. Source code is rigid. But when I think about it, when I thought about it, I was keeping in mind the JavaScript streams that we have for quite a long time now, and they work pretty well, except when they doesn't. They support multi-level piping, and this sort of piping is really transparent to the user. So you could pipe, let's say, TCP socket to a TLS protocol implementation and pipe this to maybe a speedy protocol implementation and then get the outputs and write to that stream, and everything will work by magic, but it's easy to debug and figure out in most of the cases. So the questions that I asked myself was, what if we could do the same thing in io.js? And this is what we did for the stream base, for streams in C++, and we called it in stream base. So it supports, no, it doesn't have spooky callbacks instances, so it's just one stream base class, and you could pipe its output or an input to another stream base class, so it's really singular, I don't know, in some sense, which is much better than previously. So it supports multi-level consumption, so we could implement multiple protocols in C++ and pipe them together, or in terminology of stream-based, consume them. And it has almost no black magic right now. It's quite much simpler than it was. And performance is the same, so it's great. Still, there is some stuff that needs to be done in order to make it public, and this is following. We need to implement a way to unconsume and pipe the stream base from another stream, because we have similar stuff in JavaScript, and I guess some people may want to do it in C++ too. And API still needs to be cleaned up a bit. So let's make it public. That's what I want, at least. Because it's cool, because it has great performance, both in core, and I guess it will have the same performance in userland, because you could avoid JavaScript altogether. And HTTP2 could be implemented on top of it, and it will have really amazing performance. And the last reason is that users know better how this code should look like, because we did this for users, and yeah, they know better. Okay, some stuff that I would like to suggest you to take a look at if you will ever want to dig in the C++ internal. So I suggest you to clone the io.js or Node.js repo, open CRC folder, go through files here, check what you learned, fix if we have wrong somewhere, or perhaps if we wrote some code that doesn't look right to you. Send a pull request to us, and have fun. Yeah, that's it. Thank you.
All right, so questions. There's a question over here. Second row.
Hello.
Hi.
Thank you for your presentation. I have 2 questions. First is about libUI and JavaScript event loop. If we refer to libUI documentation, we can see it has a thread pool of fixed size, by default is 4, and it's for specific kind of workload. It's for file operations, DNS operations, and documentation said a user code. Yeah. JavaScript event loop and this thread pool, how they relate to each other? Does code we write to io.js run under this thread pool or not? And the second question is about async wraps. I know there are some undocumented features like process underscore get active handles and process underscore get active requests. Is it one-to-one binding or it is another kind of things?
Okay, we'll answer the first question. So there is indeed a thread pool in libv, and this thread pool isn't actually used for anything except the file system stuff and networking stuff like that. So it's just for this. I guess eventually JavaScript will run on some sort of thread pool too. And we did lots of work in Node.js and io.js, like preliminary work for this. So there is support for running in threads, but it's unfinished yet. And I guess, as far as I remember, there was a pull request or issue on io.js repo that was mentioning creating some sort of lightweight threads that wasn't sort of like web workers in browsers, right? So when this will come out of the GitHub, it will be available for users, but for now, the thread pool runs only for internal libv stuff and for C++ bindings that the users wrote. So if they, for example, wrote the binding for the database, like MySQL or something like this, they could choose the C++ stuff to run on the thread pool. This is possible in C++, but it's not possible in JavaScript yet. Could I please ask you about the second question, because I don't think that I got it right, sorry.
It's about async wraps.
Yeah.
And undocumented features on process like underscore get active requests and get active handles. Do it relate to each other or not?
Okay, yeah. It is related, but not always. It's probably the simplest answer that I could give you. So not every async wrap object has actual libv handle that performs some asynchronous stuff. So for example, that leap, well, not that leap, it might be hard to get an example off the top of my head. Okay, so basically process.get underscore get active handles returns the active libuv handles. And not every async wrap instance has a libuv handle associated with it, because it's very, very generic and it does nothing but just mapping from the C++ to the JavaScript object. So it doesn't necessarily need to have some libuv stuff in it. Yeah, so it's not necessarily this. And tracing APIs that will be introduced will work probably in some another way. It was actually probably one of the main reasons why 0.12 was delayed, because we tried to figure out how this tracing API was working. So we haven't. We just removed it. Oh, yeah, but yeah, okay, it's fine. Yeah.
More questions? Can see anyone? Okay, can we pass the mic over there? Oh yeah, you were saying on Twitter. Sorry, I could not hear you. Okay, let's see about that. What do you think about the new JavaScript engine Microsoft called Chakra?
Nothing. I've seen Microsoft /Node repository, but it came out at the time when we was traveling, so I didn't have a really good internet connection and wasn't able to clone it and play with it. In particular, I know nothing about its implementation yet, but I will definitely take a look. So if you want to hear something more than thoughts, you could probably email me. And yeah, my email is kind of public thing and should be easy to figure out by just first and last name.
So I was wondering if we're going to get political here, and we're totally going to. Are you glad you hit the fork button? Are you in favor of reconciliation with Node?
My vote was 0 on this. The reason is that I probably don't have a special opinion as long as we can shape the releases regularly. So if we want there is nothing to prevent us from forking it again. But yeah, I think it should be fine from now. I'm pretty impressed with the activities that we have on Node Foundation, and impressed with the stuff that guys prepared for us to reconcile. So I'm very optimistic about it right now.
I think we've established already and clear that it's going to be called whatever it's called today, JS. We'll see about that. And another question, political question. If official io.js merges with Node again, what do you think it will mean for the governance model?
I don't think that anything is going to change. I'm not really like lawyer and political guy, and I wasn't one that like put all this stuff together with governance. It was Michael and probably other people, but I guess nothing should be changed. Otherwise, I don't see why people was so happy about it. Okay.
Any more questions from the audience, since we are political right now? So, any uncomfortable? Oh, there is an uncomfortable question right there.
Thank you.
Just shout.
We switch to topic Chakra, and in the same direction, what is your opinion about the JavaScript core or the Nitro from Apple? Because that's also implemented in C, C++, and I play around with the Objective-C API, and I have the problem that the same what you're talking about, you don't have anything, no network, no timeout, etc. And for me, it's interesting, is it easy to port the Node C++ code in this direction?
Yeah, it should be possible. Well, there are at least two reasons for this. First of all, Microsoft did this for Chakra. And second reason is some guy did it for SpiderMonkey. And as far as I remember, he just provided wrappers that looked like V8 API. So he created a header for the SpiderMonkey that looked essentially like V8 does. So Node just wasn't giving anything about it, so it just was using it. Generally, I am really impressed by the JavaScript core because like I'm a bit of a compiler junkie too. And they have, as far as I remember, 3 compilers. One is interpreter, and the second is unoptimized, and third is optimized code. So it's kind of it was always very interesting to me. I guess it depends on your needs. So that's probably the right answer. If you need to have whole Node.js API, then I would suggest to try mapping the V8 headers and pretending that the JavaScript course that you have is actually V8 for Node.js, and it should be possible. But if you don't need all this stuff, you could probably try to have some sort of minimal core with just libuv, and it will probably serve your needs as well as, pretending. Yeah, that's it.
Thanks.
So I think we're done with questions. We're going to have lunch in a second. I'm personally pretty excited about like the merging back of like io.js to Node. I feel like the breaking up kind of had to happen in a way, so now we can collaborate better. So I don't know, there was a little bit of drama for a little bit, but now I think we're better off with that and some better like collaboration tools in place. Like I'm really impressed with how like all the TC meetings are going for io.js and releases are great. So I'm excited. I hope everyone else is excited as well. Thank you, Fedor, for this awesome deep dive talk. And we will have lunch now for an hour and a half. So everyone enjoy the food.